right, welcome everybody to another episode of the Puget Systems Podcast. We are live again today. This time we're going to, as on the splash, we're going to be going over the recent testing benchmark performance results for the NVIDIA GeForce RTX 5080 and 5090. So this will be pretty cool. As I usually like to do, I'm going to go around the circle here, have everybody introduce themselves, say a little bit about who you are and what you do. We'll go clockwise. We'll start with Evan.
Yeah, I'm Evan. My official title is hardware analyst. I think I do most of the hands-on testing with hardware. So like this article that we're going to be going through, I did basically all the testing for. And then I do similar things for most of our other review articles, as well as slightly more tech-focused articles. So like looking at chipsets, what those give you, or looking at like maybe like does RAM speed matter? So a lot of kind of the more hardware-specific sort of things, but within the workflows that like our experts on workflows think are useful to test.
Right. And Kelly?
Hey, I'm Kelly. I'm the game dev and 3D modeling and rendering advisor here at Puget Systems. I tackle anything from Unreal Engine to all the different rendering engines, be it Cinema 4D, Redshift, Blender, V-Ray. Hopefully get some more stuff in there soon. And then generally anything 3D as far as modeling and animation.
Nice. Well, thank you. And Peter.
Yeah, I'm Peter. I'm with media and entertainment, so I'm kind of bridging the gap between a lot of the workflows that people are doing in the field, and trying to see how that works with different software applications and the hardware we're recommending and researching and everything else. I'm covering a wide range of topics, things from like photography, graphic design, video production, and a little bit into more like virtual production, but from the production side of things, not as much of what the environments consist of.
Okay, cool. Right on. Well, again, thanks everybody for joining us today. So I guess we'll just jump right into it. We'll start at the I'll show the article, and let me I'll get the link into the chat for everybody if you want to follow along. And we'll just start at the beginning, I suppose. I feel like the first part of this is really kind of Evan's wheelhouse.
Yeah.
So I guess what's this is this a big jump from last time?
Yeah, so I can give kind of a brief overview. The answer to whether it's a big jump from last time depends on what you're asking about. So from like really big picture hardware sides, the 5090, absolutely. Yeah, that thing's a monster, right? You compare it to like the 4090, it's basically like 50% more CUDA cores, roughly 40%, something like that. It's basically the same clock speed. VRAM bandwidth has gone up like 70%. Power draw has gone up 30-ish%, right? So like it's a massive GPU on the physical GPU die. Okay. Tons of CUDA cores, tons of all these other things. As a tradition, right, there's like a bunch of media encoders in there. They have a bunch of ray tracing cores, tensor cores, all of that stuff. Basically, all of those are new generation as well, right? So we're on Blackwell architecture now. So the CUDA cores are fancier. We have next-gen tensor and RT cores, so those should be better performance. And there's just a very large in terms of specs upgrade from the 4090. With the one drawback, of course, being that really like kind of eye-watering 575 watt power draw. Multi GPUs with these is difficult, but like overall, like it is a $2,000 graphics card, right? So it's not cheap, but you're kind of getting what you pay for in terms of specs. The things I really love about this generation is 32 gigs of VRAM. Finally, we're getting more VRAM. And then the VRAM bandwidth going up to like 1.8 terabytes per second. The last few generations, NVIDIA's been frankly a little bit bad about giving us good VRAM bandwidth. In some places, it even like regressed a little bit. So seeing that go up again is great. Whether or not it's important for an app depends, but like there's certain apps which really need high VRAM bandwidth. So it's kind of silly that there was definitely areas where it looked like NVIDIA was bottlenecking themselves by just like not having a wider bus.
Okay. All right.
So that's good. The 5080 is a little bit more, I don't want to say disappointing, but it's much more similar to a 4080 or 4080 Super than like the 5090 is to a 4090. So comparing to the Super, right, they're the same price. They have the same amount of VRAM. They have basically the same number of CUDA cores, basically the same clock. The only real difference is the 5080 has a little bit more VRAM bandwidth. Again, that's a good thing. And it draws a little bit more power, but 360 watts is not a huge jump from 320.
Sure.
So overall, the 5080 like looks a lot less kind of impressive on paper from the 4080 Super. I'm glad they didn't try to push up the price tag again like they did on 40 series. I'm disappointed that it's only 16 gigs of VRAM on a $1,000 card. I think that's kind of silly. But otherwise, like the specs, I expect it to be, better than a 4080 Super for like theoretically the same price MSRP. And that's like only a good thing.
Yeah. It is interesting to see just in this chart, like the comparisons in just the raw specs like this, and then knowing, kind of jumping ahead, spoilers in my own head, knowing like how some of these performance results are going to come across is, I think it all just it ends up coming back around to CUDA, right? Like everybody just leverages CUDA because NVIDIA. And
yeah, the big thing, like when you're comparing, you can't compare. So like we use shader units, right, in this chart to compare like the 7900 XTX to the 5080, and the B580, same thing. Technically, that's not even how they're organized, really. AMD reports something else. Intel reports XE cores. And like you can break those into shader units, but when you're comparing across manufacturers, but honestly, even across like generations of cards, they're not directly comparable. NVIDIA is the closest because CUDA cores are mostly similarly functional. But even once you get from like 20 series CUDA cores to 40 series or 50 series CUDA cores, like they're not quite the same thing. So comparing the raw counts is more academic than anything, but it is shocking, I think, to look at like 2080 Ti. That's the top end for that generation, 4,000 CUDA cores.
Sure.
5090 is like what, 20,000? Like it's a massive jump, right?
Huge.
That's like 5x. So like NVIDIA has been really pushing just like kind of raw silicon to try and get performance.
Well, and and then pushing a lot of electrons through that too. All right, so yeah, we've the test setup and stuff's all the same across the board.
Basically the only small note there is we used a 9950X. We think it's comparable with the other top end CPUs. It simplifies some stuff by not having an iGPU that tries to take over in most workloads. There are a few areas in specific like raw tests where we think it might actually be bottlenecking us a little bit. We need to look into that more. But just places where we're not seeing as much differentiation as we normally expect. But for a lot of our workflows, we think it is probably the best one to do GPU testing with. So,
all right, cool. That's good to know. Yeah. All right, so I guess we'll jump over to Peter. We'll get started with the Adobe Premiere Pro results.
Yeah, it was pretty cool to see. There's a lot of, with the 50 series, there are some cool features that they were announcing, more specifically the support for 422 chroma subsampling. It's interesting to see that, this format has been around for a long time, coming from cameras, but since I joined, I've learned a lot about just different support from different software applications, and figuring out like, this bottleneck really occurred just from this, a codec incompatibility issue or something like that. So with 422 support, and just as like a disclaimer, like there's still some implementation from software vendors. So support for Blackwell, I know with Premiere is not yet implemented. Their beta version is still being worked on currently, but hoping to see for like certain codecs and formats from certain camera manufacturers, we'll see some performance differences will be, or how that will be affected until we actually see the release of the newest version of Premiere. But outside of that, yeah, I would say with like the 5080, feel like would be just from looking at general specs and everything, would be like a good graphics card for a lot of people in like video editing, and where you do need those extra the extra decoders to help process some of your image. There's a little bit of increase in raw processing raw footage. It's not too much of a increase from previous generations. So it wouldn't be much of like an upgrade based off that, but
Sure.
I think if you're like, depending on what kind of footage you're working with, like if you're working with like a lot of like DJI cameras or Sony or things that don't utilize as much raw footage, you'd probably be looking at like a 5080. And if you want to spend the money on a 5090, but it's really, you're mostly looking at the decoding feature out of these GPUs.
Yeah. That's an interesting point to make.
You'll get just better performance out of it.
Yeah. There's some other articles we have that break that down between Premiere Pro and DaVinci Resolve. And it's always interesting to me to see, as a sort of the average person, average consumer in this conversation, it is surprising to me that would even be a consideration of like, what am I recording in, what codec, even the camera, and then also the software that you're using. There's all these different nuances to it that it's always surprising to me that like, why can't it all just support everything? I don't know.
Yeah. Why can't everyone just work together to make it easier throughout the whole pipeline?
Was there anything that stood out with this one that was any surprising or like it should have performed better than or the other way around?
I mean, I was hoping for like a little bit more VRAM bandwidth. I think that would be something that would have been nice to have seen. But from my perspective, just having 2 decoders and was probably the biggest factor for at least processing and getting better playtime performance out of your footage. Like I said, it's also hard to see because I haven't had a chance to actually dive in. Due to like availability on our end for hardware to test, but also just because Premiere isn't. I want to say like some of our early tests show some really cool results. Some that are not as interesting, but I also want to see once Premiere is fully updated and dive in a little bit harder. Yeah, more into this.
All right. And it always seems to, we're going to go onto After Effects, I suppose. This one makes a lot more sense where a powerful graphics card is really going to kind of shine here because it's like a little bit of 3D. I know After Effects is starting to dabble into 3D stuff, but it's the motion graphics and VFX work and things like that.
Yeah, I think with After Effects, I mean, they're making a lot of changes to the application. Right now, last month they made a change in their how they process or use RAM for previewing frames in a composition. And if you haven't checked that out, it's pretty cool. I think it'll lower the threshold for RAM. But in terms of like using it, After Effects is trying to use the GPU a little bit more in some of their workflows, and it seems like they're really trying to incorporate a lot of their 3D applications into After Effects and creating more of a pipeline. So instead of going like the Illustrator to After Effects to 2.5D workflow, they're trying to incorporate some of their Substance, Cinema 4D, and other applications that can be finished up or touched up on in After Effects. So having like multi-frame rendering and just different options available to use the GPU for rendering out and processing their compositions yeah, I think is it's really making the GPU more pronounced in those workflows. Yeah.
I want to grab this question from YouTube real quick. Jacob Gago, I believe. Any thoughts on the 285K and 9950X? Would the results differ? And I think Evan kind of touched on this earlier about QuickSync and some of the codec work and things like that.
Yeah, I can maybe touch on that a bit more. For the most part, no. So the issue is it depends, as always. When you look at the overall results like the overall scores, yeah, there's going to be a bit of movement. I'd have to like double check where exactly it is, but I think like in After Effects, you might see a slightly higher score with 285K. You might see a slightly lower score in DaVinci Resolve. The difficulty is twofold. First, if you don't disable the iGPU, then some applications will use QuickSync for certain parts of the media encode or decode. And so that could actually give potentially better or worse performance depending on how the iGPU stacks up to the NVIDIA encoders. But also it would just muddy the data, right? Because now every GPU is going to be using that encoder. And so essentially like your long op or interframe score is kind of useless as actually looking at the GPUs. So that's the big thing. Other than that, we wouldn't really expect the relative scores to change, right? So unless there's like a really severe bottleneck on the CPU side, which there shouldn't be with the 9950X, basically like all the GPUs will shift the same way. But so there's a little bit of relative change, but like a little bit of absolute change, but like relative, it should be the same.
Okay.
And I think it's how you just posted it, but we do have the 200S article, and so you can kind of see like they trade off a lot. But the big thing in that is with the iGPU. So like Premiere Pro, DaVinci Resolve, the iGPU does a lot of work by really helping out in like the long op codecs.
All right. Okay. Cool.
Well, and we also in our benchmarking, we have to try to balance what our recommendation is going to be for the entire system versus what we're going to benchmark a GPU on. Because like there might be a slight difference between Intel and Ryzen on these, but is that difference going to offset the CPU performance difference for that same software? And so the other option is to find out what the best CPU is and then run all the GPU tests on that CPU for that software. But then we're like have a whole bunch of test beds going on, and which is possible, but also like then you throw in a lot of my recommended hardware, recommended CPUs are on Threadripper, and like that's a whole different thing than all these other guys. So it just gets to be a lot of balance, and we just have to pick one so we can try to eliminate the CPU from the GPU performance. And by just doing everything on one, it makes it more like we can just focus on this one aspect.
That's a good point.
Threadripper was actually the big one in contention. So like I didn't think too much about Intel versus AMD. I was kind of like, once we were settled on desktop, I was like, we'll just use AMD. It simplifies stuff more, and it's basically the same performance. The big question was actually Threadripper. Historically, we did all our GPU testing on Threadripper. We think that 9950X is actually a little bit better balanced of a CPU for GPU reviews than Threadripper is right now. Just because of kind of how the way Threadripper has gone. It's no longer like desktop plus, it's now like workstation or server minus. So it's just its performance characteristics are different than they were in the past. And so I think in the future, most of our GPU reviews will be on the 9950X going forward for a while, just so that it's easier to compare between reviews. But it's definitely something we kind of think about every time we have to start a new review process is what we want to use.
There was another little, I suppose, mildly off-topic question, but this might kind of relate because we were kind of talking about CPUs and the choice in that. King Dranzer asked, is there any shift for some pro software where they're being worked to utilize and take advantage of X3D CPUs from AMD? I posted the link to our 9800X3D content creation review that I think might help answer that. But if there's any quick insight.
The other thing I would add to that, beyond what is in the article, is that currently we only have the 9800X3D available in the market. So we can't answer how it's going to improve for the 9900, 9950X, which are the CPUs that usually do better for our software anyways. The 9800 is kind of on the lower end for a lot of professional use cases. So we'll see more when those actually come out and we can actually do testing. In the past, it was basically what he said, that it Unreal Engine worked great for it, which makes sense because it works great in games and it's a game engine. And then other softwares just don't leverage it. A lot of softwares I don't think are going to benefit from 3D cache, even if they try to tailor some of their software to take advantage of it, just because it really benefits from a lot of continuous read writes and like grabbing that cache over and over and over, which games do because they're constantly moving assets in and out of memory and has all this other stuff happening that needs to be referenced at any given time. Whereas in, processing a video doesn't really do it that much. It's all loaded in cache or into RAM anyways. And like, it might help a little bit, but maybe not enough. So, but we'll see when we get the new CPUs, because some of it is, how does AMD implement it versus how does the software implement it? Like there's a big balance. So we'll have a better answer whenever they're available, whenever that might be. I don't know right now.
Yeah. And another one from Jacob Gago. And I think we kind of touched on this a little bit earlier. I know the 5090s now have H.264 support, but is someone really missing out on Intel QuickSync and NPU for AI if they go with AMD? I get the feeling like not really.
Yeah,
I even kind of touched on that, but go ahead, Peter.
It kind of depends. We haven't had a chance to really test QuickSync versus NVDEC, and it's something that is on our list because I'm also curious to see what the performance difference is with just that decoding hardware between each. There might be some support with certain codecs that QuickSync still is compatible with that NVENC and NVDEC might not be compatible with. These are things that we have to research and we'll post about in the future. So I don't want to concretely say or like provide any misleading information, but I also want to say that like H.264, especially like 10-bit 422, hasn't been available on any hardware in general, even though like cameras record in this format a lot. Like just getting having this be available is pretty new in general to like the whole entire market. So it'll be interesting to see like how future products, if they like actually adapt H.264 into their applications, as well as if camera manufacturers even continue with this or if they try to expand, because there are other codecs out there like EV1 a little bit more available as well.
As for the NPU, no.
No. All right, we'll get back to the article. We'll jump to DaVinci Resolve now. So how did this one stand out for you, Peter?
Yeah, so there's like a version of Resolve that wasn't available to the public that we were able to kind of test out the Blackwell architecture on this. And I will say from my perspective for video editing, I was really excited. Loading up actual H.264 10-bit 422 footage into Resolve, it was very buttery. There's no real issues. It wasn't like an actual project where I was able to dive in, add a bunch of effects, and see how like a full-on project would play with multiple assets coming in. But in terms of like processing footage from let's just say like a Panasonic that shot H.264 at I think it was like 400, a bit rate of 400, but in the 422 format, there's no lag. It was seamless playback. So definitely that hardware decoding feature is definitely helpful and very exciting. In terms of the scores, I'm just going through some of these, and overall it's pretty exciting, and just seeing how how much it's going to help users really is exciting to see what will happen once the public version of Resolve comes out, and see if there's any other features that get updated.
I like seeing this trend of the previous generation sort of 80, whatever, X80 Ti or just X80, supers and stuff. There seems to be a trend of where they're about equal or more powerful than the previous generation's 90 model, which is pretty cool. I mean, we can talk about cost and stuff and how that's a little, it hurts the pocketbook a little bit, but it is cool to see that it does seem to have that sort of trend where I always have this feeling of the 90s. They shouldn't have changed it from the Titans, but that's an opinion piece we don't have to get into. But it is cool to see that what used to be the sort of top end card is now every generation is kind of equaling the more like professional level stuff, and it's just cool to see that progression.
Yeah. The one comment I think on DaVinci Resolve that I noticed when I was doing testing is the AI results are a little bit low. So I'm hopeful that in the future that's going to be something that gets kind of fixed with like software driver updates. But also just like a kind of word of warning that with the most recent DaVinci Resolve release, it's really not compatible with 50 series cards yet. So we're still waiting on the public version of DaVinci Resolve that lets you use them. There's an issue with like the neural engine optimization in DaVinci Resolve where it doesn't complete and you kind of get soft locked booting up with 50 series cards. I don't know if you disable that feature, if it lets you go forward and then you just have bad neural engine performance. But yeah, so we are a little bit of growing pains with the new 50 series to be aware of.
Okay. And what sort of tools or features in DaVinci Resolve is this testing?
Ooh, I could tell you if I were at my work computer. But
okay. No, that's okay.
I'm sick today, unfortunately, so I can't off the top of my head rattle those off. Peter might know, but we test a lot of features, so knowing exactly which ones are looked at in this score is difficult. There's like over 100 subtests I think that we do. So
wow. Yeah. Okay. Yeah.
Top of mind. I know. What is it? Scene edit detection would be one. What was it? It's a magic mask. I can't remember the name top of mind, but just like draw a line and creates a mask. I think super resolution is another one. It's nothing that would really, I think, like affect a workflow too much. It's more like little enhancement tools that just make your life a little bit easier.
Okay, cool. Right on. All right. That brings us to one of my favorites, Unreal Engine.
Mm-hmm. Yeah, so in Unreal Engine, we start to see a little bit of an improvement. It's worth noting that for all this testing, I have DLSS, frame generation, all those features disabled because we want to look at just the raw power of the GPU, how much you can compute. Also, it's kind of a interesting benchmark for development purposes because there's not a lot of need to have a high frame rate while you're developing a game.
Sure.
Or it doesn't really improve your ability to make something if you're getting 140 FPS versus 100. Like, it would apply to things like GPU light mass, where you're still baking lighting, but you're using the GPU to do that. But again, that wouldn't utilize DLSS or frame generation anyway. So you want to know what the raw performance of the GPU is for that task. So we could get higher results if we enabled some of that stuff, but it kind of doesn't really make a whole lot of sense. But we do see a nice uptick for the 5090.
Yeah.
A little bit lower, or quite a bit lower for the 5080. But the bigger benefit for the 5090 is that higher VRAM, which is a big deal for virtual production, or people that are really pushing high fidelity graphics. They're only trying to get 30 FPS anyways. Like, they don't care about high frame rate. They just want to put as much stuff into the scene as possible. As you start to increase the amount of stuff in the scene, or the resolution, all that kind of stuff, your VRAM starts to escalate very quickly. And if you run out of VRAM, then everything slows down. So the 5090 will allow you to do more in your scene at higher resolutions than the 50 or the 4090 would have. So that's a great win all around. Whereas the 5080 versus 4080, it's going to be about the same, slightly faster, same total VRAM. So you're not going to be able to do bigger scenes than you could before. But maybe you could use the codec once you're done rendering and want to export something. I don't know. But the new encode and decode hardware doesn't really apply to Unreal Engine too much.
No, that makes sense though. Yeah, that's really more for the video editing side of things.
Yeah. We would have hoped for a much bigger gain, like we had seen in previous generations, like from the 3090 to the 4090 was a massive jump. From the 4090 to 5090 is not quite so big.
Oh yeah, that's huge.
The 3080 to the 4080 was also a big jump, and the 4080 to 5080 is not a big jump. That's kind of disappointing in that sense. Just we're used to these larger performance improvements generation over generation. So that is what it is.
Yeah.
And again, the new software features that NVIDIA touts are great for end users, for game players, but not necessarily for development tasks.
Yeah. Okay. And there was mention of maybe drivers being an issue in some of the previous results. Would that apply here as well?
I wouldn't be surprised at all if with future driver updates that this gets better. That's somewhat typical for these releases anyways. We also, as we get to in the rendering section here in a bit, some things just don't work at all with the 5090 or the 50 series. So maybe if there's an update to Unreal Engine to better leverage some of this stuff, we'll see a better improvement. But for right now, right out of the box, it's good.
Yeah. Which is a perfect segue into the next section.
Yeah.
Our rendering, V-Ray, and Blender.
Right. So rendering this time around, we only have 2 benchmarks to go off of because Octane and Cinebench did not work with the 50 series. It would recognize them, but then say that it's not compatible or something like that, and they wouldn't run. For Cinebench, which is actually Redshift, Maxon has said that they have a preview build available of Redshift that you can download, or an experimental build. I can't remember what they call it, that works with the 50 series. If you want to use an experimental build for your renders, that's available. Or you're gonna have to wait until official support comes out. Same thing with Octane. I'm not sure where Octane is at. Their benchmark hasn't been updated since, what was it, 2020?
Oh, wow.
It's quite old. I don't know if they're going to update Octane Bench for this or not, or if a driver update will fix it. It's a little weird because we didn't need to do that for the 40 series. It just worked. Don't know why the 50 series is different. We don't know what NVIDIA changed to make it not work with these renderers.
Strange. That seems really weird.
Yeah. But when we take a look at what scores we do have, we can see that the 4090 versus 5090 is a really good improvement for rendering. So people are doing GPU rendering with V-Ray or Blender, and hopefully also this will extend to Redshift. The 5090 is a pretty nice improvement. Again, not as big as we saw in the past, but still like 40 to 50% faster renders is nothing to sneeze at.
Yeah.
The 5080, we do actually see a good improvement, especially in V-Ray. Blender's less of an improvement. If that's enough to get someone to upgrade, that's going to be a tough call for them. But it is better if you're on a 30 series and looking to finally upgrade. It's definitely worth going to the 50 series over the 40 series. Whereas some of the other software packages, you might look at the price. If you can get a good deal on a 40 series, that might be the better way to go. Whereas in V-Ray, probably just worth getting the 50 series if you can get one. If you can get one at retail price, that is.
Sure.
I don't know what the aftermarket prices are currently. Sometimes after launches they get crazy.
Yeah, there's a lot of talk of the paper launch and that kind of stuff that the stock is hard to come by right now. Which, again, not to go down to an opinion piece sort of talk, but I do remember hearing that. And again, rumors that NVIDIA had either stopped or slowed production of the 40 series well ahead of this, before even the announcement of 50 series stuff. So it's interesting to hear that. It's interesting, but at the same time, almost expected nowadays. Like, everybody just buys up these cards the moment they're even available.
That's usually the way NVIDIA does it. With every other generation before this, at some point they have to switch over the fabrications from 40 series to 50 series. Can't really do both at the same time,
right?
Or have multiple different lines, one for 40, one for 50. Like, they just switch everything over. When they did it this time, I don't know. But that's what they have to do at some point. Why we don't have a better supply, I couldn't tell you that.
Yeah, I will. Two notes on that. The first is this is kind of especially the case that they can't just run both lines in parallel, is that they didn't change process nodes for this generation from last generation. Typically, they see a lot of improvements when they can do that process node jump because they can just be more efficient, so they can kind of cram even more stuff into the GPU. And not draw a ton of power, right? So efficiency curves are better. They didn't do this time. So during the same process node, they had to basically choose, I think, for the most part, like, which GPU are you making? There's also a lot of demand for GPUs right now, especially really high-end GPUs, so I'm sure that's cutting into supply. And I know last year we were hearing rumors about production issues with Blackwell. So I also wonder if that just meant that they had less of a head start on making supply, but we've definitely seen a shortage of 40 series kind of in the wild. So it definitely looks like those probably had stopped being produced some time ago. But I'm not positive on that.
Mm-hmm. Before we move on, I'll grab this one. This is the second question from Jacob Gago from earlier. Putting aside what social media has said about the 285K stability issues, it'll be nice to hear each of you quickly say what you would pair your 5090 with, a Ryzen 9 9950K or Intel Ultra 9 285K.
If I were buying a system right now for general purpose use, not for gaming exclusively, I'd buy a 285K.
Yeah, I probably would as well. If I was buying it for myself, I wouldn't be buying a 5090. or a 285K. I'd probably get I forget what the i7 is.
The 265.
Or I guess it's not even an i7. The
Well,
Ultra 7. Probably around there, just a better value for gaming. But But yeah, the 5090, I probably wouldn't do that either. It's just too much.
How about you, Peter?
Yeah, probably for just like editing or any photo tasks, I'd probably go 285K and a 5080 instead of a 5090. Rather spend that extra grand on something else.
More storage, you know.
If I was doing this for game development, I would probably do 5080, 4080, one of those two, based on what I can get, and a Threadripper anyways. Like, I would trade, don't need the highest end to develop a game, but the CPU benefit from Threadripper would be very nice.
Oh, cool.
Houston, what would you get?
Oh man. I'm with you guys. I wouldn't get a 5090 with just the power draw. I'm a small form factor person myself. I like
It's
my
only
tiny
two
boxes.
slots.
Oh, it's not the size; it's the power draw. You can barely get 1,000-watt power supply nowadays into a shoebox. So I'd probably avoid that too. I'd probably do it with the 5080, and I'm kind of AMD now. I'd probably do more the 9800X, 9900X, a little step down from the top end, and yeah, put the extra money toward an 8 terabyte NVMe or something.
True. I guess if I was doing gaming, it would be the 9800X 3D.
Oh yeah, this is like my like personal like gaming system. It's a 9800X 3D all the way.
Sure.
Yeah, that's not a question.
Right on. I mean, we're kind of close to the end. We kind of went through this pretty quick. We didn't get as many questions as we normally do and things like that. This was a bit of a chaotic entry into our podcast this time around. So we are at the end. I guess we'll just kind of wrap it up. Unless there's a few more questions. Do you guys have any last comments or anything? I don't mind this being a little short. So
I can talk forever, so I have a few comments. I will say, I know it's talked about a little bit in the chat, and Kelly mentioned it a little bit. This has been one of the more volatile NVIDIA launches that I think I've ever seen. Like, there's been a lot of software incompatibilities. There's been some driver weirdness. I know people have been reporting some nonsense with like driver updates causing GPUs to fail. This is like very uncharacteristic for NVIDIA. Usually their updates are tight, really well done. I think part of it, I know that we had a late release so we're on a new CUDA version with this GPU. We're on CUDA 12.8 for full feature support. I know that wasn't put out until after the GPUs launched. And so software vendors need to integrate that into their software to have full support, as well as just, there's some other quirks with stuff. So I fully expect that 6 months from now we're going to see at least slightly better performance, and probably most applications will have figured out their support issues, and so everything will be working totally fine. But it is a little bit weird. It's also doubly unfortunate that if you are looking for a new GPU right now, you kind of have to buy a 50 series because 40 series don't exist. Like 50 series are also hard to buy, but so if you kind of want the, for your value better GPU, you then have some weird software support. But I think we expect that to be fixed in the relatively near future, now that the toolkit's out and software vendors can start doing that.
And Houston, I just put in a link to NVIDIA's customer support where they talk about which applications support the 50 series, and if they don't, when the ETA of support is coming for that software. So if there is a specific piece of software that people out there are interested in that may or may not work right now, you can follow that page to see when to expect some updates before you commit to buying anything.
Awesome. Thanks for that. That's super helpful. Yeah, right on. I'll try and get that into the description of this after we're finished, at least on YouTube. So yeah, that's pretty cool. Peter, do you have any closing thoughts, comments?
I think that's a no.
I feel like Peter's off in. He's our foreign correspondent.
Oh, I didn't know.
Through our microwave connection.
You cut on my end. You cut out as soon as
I'm sorry.
asked a question. So
just any final final comments or anything about this particular release?
yeah, as much as I want to give some more detailed insights, I'm still personally waiting on some of these applications to support these GPUs so I can provide a little bit more insights. I think the 422 format has taken up a lot of my focus and just seeing like how this performs, but I also don't want to stray away from like other camera formats like shooting in RAW, like whether you're on ARRI or Red or Blackmagic, and seeing how that performs. Like we have tests, but I would like to see with the applications incorporating this how that changes things, because I know like everyone's like, oh, I have 6K and 8K. It's like, well, we're always trying to push limitations. So what is the limitation, and trying to figure out where these GPUs kind of push us. So we'd love to give more insights, but yeah, again, I don't want to
Wait,
tease
so
for
Peter,
something that I don't even know about.
Peter, I can finally work with all my workflows without creating proxies or anything.
Proxies are
Don't even get me started. I'm just kidding. Proxies will never die. They are the zombie that keeps coming up from the grave.
I guess, sorry, the one other thing, we should have an article looking at AI applications, so generative stuff like some LLM stuff, some Stable Diffusion, as well as some more kind of like theoretically like in production, like software things like Topaz Video AI, a little bit more detailed on like the DaVinci Resolve AI results. We should have an article with that coming out soon-ish. John Allman, our AI guy, is working on that right now. And so hopefully, I don't know what the current plan is. Hopefully, I think sometime later this week, but have that out. And so that should be interesting as well. And then, of course, in the future, we'll be having articles on like the 5070 Ti when those are released sometime. I don't remember if NVIDIA has said when those are coming out. I think like February or something. So yeah, cool. Which I guess is February's now, but
and I guess with this driver funniness, will we see updates to these articles as things change? I can't imagine we'll publish a whole new one, but just we may put a little
these articles. Oh yeah, so I think we're kind of hoping it will be fixed mostly by time we're doing like the 5070 cards, and then we're planning on doing a larger roundup article. If there's still issues there, then yeah, we'll keep checking back, and we'll like at the very least toss a banner or something on articles and say like, hey, there were these issues. You can see our updated results or whatnot. You know, wherever we have those.
Yeah. Similar to what we've done with the Intel stuff, I imagine. Yeah. Okay.
Yeah.
Cool. All right. Well, I mean, only 10 or 12 minutes short, but that's okay. Thank you guys for joining me today and going over the results of stuff. This has been a little bit of a weird one, I think. It seems we saw some interesting results. We saw some things that I'm surprised half of the rendering stuff wasn't working right, and just weird, just a little weird. So, but thank you guys for joining me today. Thank the audience as well for joining us. We try and do this every month, and the next one might not be live. I will be like in the chat or something as we broadcast the recording. But subscribe to the channel, follow us on social media and stuff, and stay tuned. And we'll see you next time. So thanks everybody, and we'll see you.